Alright, today's lesson is about graphing exponential functions. Now, for these problems, we will not be using a calculator, so watch very carefully how we do it. Let me zoom in a little bit. So, looking at the first problem, 3 to the x power. So, this means we will have 3 to the negative 2 power at first. Now, a negative power means you drop that thing down. So this is like 1 over 3 squared, which means 1 over 9. So that's our first value. Similarly, I will now have 3 to the negative 1 power. Now, that just simply means 1/3. Then I have 3 to the 0 power. Now, anything to the 0 power is 1. And then, of course, if I did 3 to the 1 power, that's just going to be 3. And, okay, 3 to the second power is 9. So these are the values that you get. Now, 1/9 of a unit is barely above 0. So we're going to have negative 2 and then 1/9. So let me just get ready here. So negative 2 and then 1/9 of a square is so close to 0 that it's basically that dot's going to look like it's on the line. 1/3 of a square, all right, literally means a third of the way up. So it'd probably be right about there. It's a little bit up. And then finally some whole numbers. So then we have 1, and then 3, and then 9 would be here. So those are the values that we have. Now, exponential functions have an asymptote, all right? There's going to be some value that the graph gets closer and closer and closer to. And in this case, that appears to be 0. So I'm going to go ahead and show the asymptote as a dashed line like this. Alright, so this is the asymptote. And I can see the way the curve is sort of flattening out and it's getting closer and closer. It appears to touch, but I actually know that it's 1/9. So even though it looks like it's touching, I know that's not really touching. Alright, and the same thing would happen as I continue to the left. It's just going to get closer and closer to the asymptote. So it's already seeming to touch, so I know that by the time it gets over here, it's going to basically appear to be touching. So as I graph this, I'm going to start off just tracing the asymptote, but in my mind, I have to just know that it doesn't really touch. Okay, so your graph is going to look something very much like this. And this will continue like this forever in both directions. So now when we talk about the domain and the range, I guess I better zoom out a little bit. So the domain. The domain is how far it goes to the left and to the right. So this graph goes to the left and to the right forever. So that is negative infinity to positive infinity. Now the range has limits. Range, we always give the range from bottom to top. Now the asymptote forms the bottom of this graph. And in this case, the asymptote is at 0. So the range starts at 0. And then it goes up from there to infinity. So 0 to positive infinity. Alright? Now I just mentioned that the even though it appears to touch the asymptote, it's really like 1/9, 1/27. You know, it's getting smaller and smaller, but it never actually reaches 0. So you might wonder why I'm using 0 for the range. Well, we can deal with that simply by using a round parentheses on the 0 instead of the square bracket that we sometimes do. Putting a round parentheses means that the 0 itself is not included in the range. So it's everything up to 0, but not including 0 itself. Now the asymptote, I drew it. It's right here on the x-axis. But you will always write the equation of that line. And a horizontal line always has the equation y equals something. So if it's right on the x-axis, that is y equals 0. You must put y equals. Now for end behavior, first we'll do the left end behavior. So as x approaches negative infinity, all right, meaning on the left, f of x approaches. Now, as we slide to the left, the graph approaches the asymptote. So in this case, as we slide to the left, the function gets closer and closer to 0. Now, as we slide to the right, all right, or as x approaches positive infinity, the function approaches, well, let's see, as I slide to the right, it just goes up, 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 into the sky. So that's going to be positive infinity. So that's my end behavior. Okay, let's take a look at number 2. Again, we need to do this by hand. I'm going to zoom in for a sec. So as we do 1/4 to the negative 2 power. So I've got 1/4 to the negative 2 power. Now please remember that if you do a negative power on a fraction, all you have to do is do the reciprocal. So 1/4 will become 4 over 1, which is just 4. And then I can have a positive power. All right, and of course 4 squared is 16. All right, similarly 1/4 to the negative 1 power is the same thing as 4 to the positive 1 power, or just 4. All right, if I have 1/4 to the 0 power, anything to the 0 power is 1, so there you go. And if I have 1/4 to the 1 power, that's just 1/4. And finally, if I have 1/4 squared, well, 1 squared is 1, and 4 squared is 16. So that'll be 1/16. So these are the values that I need to graph. So starting off at negative 2. So at negative 2, I am at 16. So I start off way up high. All right, and then at negative 1, I've dropped all the way down to 4. At 0, I'm at 1. And then at 1, I'm all the way down to 1/4. And then at 2, I'm down to 1/16, which is already so low, it's going to basically appear to be on the line. Once again, it seems to be flattening out at 0 and approaching 0. So this is going to be my asymptote again for this problem. All right. So when I draw my curve, all right, I'm going to basically allow it to trace the asymptote on the right-hand side. Alright, it's got a little messy there on the end, but what are you going to do? Drawing with an electronic pen is difficult. But that is the basic idea for this graph. Okay, let me zoom out so we can do the domain and range and stuff. Alright, look, I might as well face it. For these exponential functions, the domain is always going to be negative infinity to positive infinity. because they will always go left forever and right forever. Now the range, once again, is going to involve the asymptote, bottom to top. So the bottom is the asymptote, which is 0. So 0 to infinity. Alright, just make sure you use a round parentheses on the 0 to reflect that we're not including the asymptote, because even though it appears to come down and touch because it's so close, in reality, in our minds, we know that it never really touches. 1/16 is close, but it never touches. 1/1,000,000 would be really close, but still not 0. So our asymptote, once again, is y equals 0. Do not forget the y equals part. So end behavior, first on the left. So as x approaches negative infinity, f of x approaches. And on the left, you see that it just goes up, 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 up. So our left end behavior will be approaching infinity. Now on the right, so as x approaches positive infinity, on the right, the function approaches the asymptote, which in this case is 0. So there's your end behavior. Alright, so here we go. We have to do 5 to the x power. So that means we're starting off with 5 to the negative 2 power, which would be 1/5 squared, which would be 1/25. And then we have 5 to the negative 1 power, which would just be 1/5. Alright, and then we have 5 to the 0 power. Anything to the 0 power is 1. And then we have 5 to the 1 power, which of course is just 5. But then we have 5 squared, which is 25. Now, 25 is not going to really fit on our graph, but we're just going to do our best. Okay, I might have to zoom out a little bit. Let's see. Alright, so first we've got at negative 2, we've got our 1/25. Okay, so clearly 1/25 is really close to 0. So that's basically going to appear to be on the line. 1/5, alright, that's a fifth of a unit. You know, I'm going to put that like an egg on the wall here. Alright, again, super close to 0. It's a fifth of a square. Now, and then at 0, we're up at 1. Okay, at 1, we're all the way up to 5. But then for 5, I mean, at x value of 2, we're supposed to jump all the way up to 25. Let me see if I can kind of fake it a little bit with some gray lines here. Okay, so let's see, I'll do the best I can. So this will be about, you know, 17, 18, 19, 20, 21, 22, 23, 24, 25. Alright, this is the best I can do, people. So 25 would be like way up here in the sky. So I think I'll have to zoom out to even graph this. But let me get it started. Well, first the asymptote. Once again, the asymptote appears to be here at 0. Show your asymptote as a dotted line. So on the left side here, it's going to appear to trace the asymptote, even though in your mind you know that it's not actually touching. Alright, and then I've got to get up there into the sky. Alright, this is going to be really ugly. Let's zoom out and take a look at that ugly thing. All right, well, it's not too bad. Oh no, that's the other function. Okay, so that is pretty ugly. Wait, that's not it either. No, okay, that's really ugly. Whatever, we did our best. Now the domain. Once again, the domain is going to be negative infinity to positive infinity because the graph goes to the left forever and it drifts to the right forever. The range is once again going to be 0 to infinity. All right, it starts from the asymptote and it goes up from there. The asymptote once again is y equals 0. Don't forget the y equals part. Now, as far as the end behavior, on the left, okay, so as x approaches negative infinity, that's the left, the function approaches 0. See, on the left, it approaches the asymptote. On the right, or as x approaches positive infinity, the function increases without bound. All right, as I slide to the right, the function just goes up, 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 up into the sky. So that is positive infinity. Okay, number 4. All right, one more problem. Please remember to do this without a calculator. Do not use your TI-30XS multi-view for this. So if we are supposed to do -2, an x value -2, that means I've got 1/5 to the -2 power. Remember, when you have a fraction with a negative exponent, you can simply do the reciprocal. So this is going to give you 5 to the +2 power, which is 25. All right, so this looks very similar to the previous problem. Now I'm going to have 1/5 to the -1 power, which is just going to be 5 to the 1 power, which is just going to be 5. And then I would have 1/5 to the 0 power. All right, anything to the 0 power is 1. But then I will have 1/5 to the 1 power, which is just 1/5. But then I will have 1/5 squared. All right, and 1/5 squared is the same thing as 1 squared over 5 squared, which is just 1 over 25. So these are my values. So starting at -2, I'm all the way up there at 25. So dare I do this again? It didn't work out too well last time, but I'm going to do it again. So because it goes off my chart, so I'll just estimate. So that'll be about 17, 18, 19, 20, 21, 22, 23, 24, 25. So at -2, I am at 25, just about there-ish. Okay, at -1, I'm way back down at 5. And then at 0, I'm at 1. Okay, and then at 1, I'm at 1/5, which is really close to 0. And then at 2, I'm at 1/25, which is so close to 0 that it's going to look like I'm at 0. And you know, it would continue like that forever. So clearly, once again, the asymptote is here on the x-axis. Go ahead and show the asymptote as a dotted line. Okay, and then the graph. So on the right hand side, you are going to appear to be tracing the asymptote, but in your mind, just know that you're not really touching it. Okay, and I don't know if I'm going to be able to do this. But the idea is it goes on up there. Nailed it. Okay, that is the idea, my friend. Okay, there's your graph as, whoa, hold on. Yeah, there's your graph as best as I can do. So, what shall we do? The domain and range, let's wrap this sucker up. So the domain is negative infinity to positive infinity because it goes left and right forever. The range is 0 to positive infinity. Bottom to top, 0 to positive infinity. We'll use round parentheses on the 0 to show that the graph never quite reaches the asymptote. So round means we are not including 0 in the range. The asymptote, like all the other problems we've done so far, is y equals 0. And the end behavior, first on the left. So as x approaches negative infinity, that means left. On the left, the function approaches, well, as we slide to the left, the function increases without bound. So that, or we could say it approaches positive infinity. Now let's do the right. So on the right, so we'll say as x approaches positive infinity, what happens to the function? Well, as we slide to the right, the function gets closer and closer to 0, the asymptote. So we'll just put 0. And I believe that is it for this lesson. Not a very long lesson. I hope it was helpful, and I will see you on the next video.